Okay, welcome. My name is Dimitris. This is one more supplementary interviews we're running for this new certificate program in medical software and medical AI. I guess this is my old friend and colleague, Hirohito Okuda. Hirohito was at Yale until 2006-7, and then ever since then, he's had an interesting career back home in Japan, first at General Electric for 10 years, then at DeNa for years. Currently, he's at Konica Minolta, where he's a principal AI engineer, directs AI engineering across the company. He leads generative AI adaptation. He works on guidelines and does reviews for AI products across the company, as well as being part of their ethical committee. So here I want to have a conversation about the challenges of using AI in medical software and software in general, and how the whole process of software engineering is changing in this new era of AI. So Hirohito, thank you for taking the time and welcome.
Yeah, thank you very much for introducing me. So it's my great pleasure to participate in your lecture. Thanks.
So I introduced what you do at Konica a little bit very quickly. Can you tell us a little bit more about your role there and what you do?
Yes. So in my current company, Konica Minolta, its major business is to product and sell multifunctional printers and medical imaging devices or sensors. So mostly some sort of imaging devices they manufacture, and I'm supervising directing the AI development for whole company. And part of my task includes supervising AI ethics committee or AI technology strategy establishment and so on.
So when you and I started in software engineering, there was no such thing as AI. We wrote all our code, we designed it, from by hand in some ways. Now we're beginning to get more and more uses for modules that we call machine learning or AI. So if you can just walk students like at a very introductory level, what are the challenges of having AI modules in a software project? How does it change the way we do things now?
Yeah. So first of all, so AI is we can see AI as a sort of software component itself, because AI is actually consists of parameter files consisting of billions of numbers, and also small software to describe the network structure. So the challenge, one of the biggest challenge is that AI is the black box. So black box I mean the behavior of the output is unpredictable and unstable. So you can't predict the output of AI deterministically. So due to model complexity, it is very difficult, or in principle hard to explain in a way you can understand. So that's the biggest point, I think. So because it's unpredictable and unstable, so you need to design verification plan to cope with an unexpected output. And also in the validation stage, you also need to devise how such instability can be handled.
Yeah. So yes, back when we're doing old unit testing, we were off by 0.01, and we thought, this is not the world we live in here. So you mentioned when we talk about statistical pass criteria. Can you explain a little bit about that?
Yes. So in old functional unit testing, if you give the function argument 0, then you can predict what the outcome should be, what expected outcome should be. But in the AI, it's difficult to predict or predetermine what the output value would be. So for each input data, you can't predict, but as a whole data set of input data, for example, you can take 100 images as an input, and you can define the pass criteria as 90% of the result is okay. So in such a way, to define pass criteria in statistical way, you can still define the reasonable testing criteria. So that's one way to cope with unpredictability.
Yeah, so that's at the validation, and the other challenge we face is, and you mentioned, is a black box. So we don't have any way to understand the output often. So how does one do risk management? How do we think about integrating? How do you communicate to the user uncertainty in some ways? What are the challenges that you see there?
Yeah, so so especially in validation stage, if the AI output is not satisfiable, then the user or your customer may ask you why AI made mistakes, or why AI output false positives. Then you have to provide understandable, acceptable explanation to your users. So that's a big challenge. So so what you can do is, at the beginning of the project or at planning stage, you have to ask and communicate with your user that users can eventually accept those unexplainable output. So actually, so explainability is a big AI research area, explainable AI, and different kind of techniques are being developed. Like so many ways are being developed, but ultimately they are not capable of explaining the results in strict manner. So
yeah, there's a lot of uncertainty. There's a lot of interest. Everybody wants an explanation, but the explanations are never going to be good enough, and you can't boil down a very high dimensional space into a very small number.
So it's I know that they made great progress in explainable AI, but it's just approximation in lower dimensional space. So it's acceptable or not, it ultimately depends on the customer's feeling. So
yeah, it's a new world. They're going to have to get used to things that work most of the time, but not all of the time.
Yeah.
So let's think a little bit more from a software engineering aspect of things, and talk about specifications and so in usual software, we have your user needs. You take the user needs, you divide them into things the software needs to do. You design code one line at a time. You test it. With AI, we have a problem of specification, right? We need something it's almost like human language. Do something differently, but translating that into a specification to a testing process is complicated. Can you talk a little bit about that aspect of how you design and how you test?
So defining a requirement specification for AI is quite challenging or tricky, I think. Because the unique aspect of AI data input is that the dataset space or size of input data is quite huge and very, very complex. So to compare, for comparison, so in traditional software component or small module, you may be able to list up all the input data combination, and you can define the output of for each input, or you can reasonably define a small set of input data enough to cover the possible inputs. But in case of AI, it's almost impossible. So different from traditional software, you can't categorize input data set into small number of set, and you can't state the requirement for each input data subset. So that's a very challenging aspect. So strictly speaking, it's hard to implement functional requirement specification for different kind of input data.
how do we think about specifications in terms of AI when it's just this one big thing, solve my problem, right? That is your user need, there's nothing more. So what is the process that you have that you're thinking about when you work through that? Can you just walk us through some?
Okay, so let me give you an example. So suppose you have to define the specific. You have to apply AI to healthy brain MRI images. So then you want to implement exceptional handling of disease data to perform AI inference for healthy images only. But it is hard due to input data space complexity. So you can state a requirement specification like brain hemorrhage shall be excluded from the input of AI inference. But how we can exclude hemorrhage images? It's hard to implement.
Yeah.
And yeah, so yeah.
It's almost like an AI algorithm that needs to prevent
the
input of
right,
an algorithm.
Right, exactly. So it actually happens when you develop algorithm. It's easy to correct normal healthy data, so you can you tend to develop algorithm or model AI based on normal data, but those AI model is tuned for healthy data, so it's much more difficult to exclude exceptional data. So it's impossible.
So how do you, one of the challenges I have seen before is how people define edge cases, right? So when we do software, we know that this parameter is between 0 and 10. We say less than 0, we throw an error, more than 10. In AI, it's almost like everything is an edge case. Right? It's like everything.
Yeah, so yeah, actually edge case is too much challenging. So maybe until several years ago, the only way is to add disclaimer in user's manual that saying this kind of exceptional data is out of scope. So that's the only thing we could do. And recently we are more tools to generate exceptional edge cases in synthetic manner. So the situation is improving, but still all the possible, so generating all the possible edge cases is impossible. So to design safe AI, so it's still challenging.
Let's talk a little bit about the other big challenge we face. So the challenge we face here is often, again, traditional software engineering. We used to think about code. We're not used to about data. Like data comes in at the end, a little bit of data there.
Yeah.
Some testing, but as you mentioned yourself earlier to me, AI is not just pure source code, right? The data plays an important role. So how do we balance the data versus code thing here?
Yes. So the output of AI model development, or actually the AI model itself, is a collection of numbers. You can read those numbers, but you can't tell what they mean. So in that sense, it's almost like a binary file. And to create that binary file or parameter file, you have code different from the product code itself. And to create the AI model itself, you use that development code and data. So when you use data for AI training, you divide data into subsets and put those subsets in complex manner. So you have to go through the complex procedure for AI training. So to get some AI model, you need data and AI code, and also complex procedure itself. So the different from traditional source code creation or source code development. The AI model itself is bundled with the data and development procedure and AI development code. So those should be packaged and controlled in a consistent manner.
Let's talk a little bit about the risks that come with AI. Again, with typical software, we can think about the risk. We know the edge cases. We know what could go wrong. It's a small space. Some of the risks with AI are the same. Some of them are different. What is your feeling about risks, both software risks, ethical risks, everything else that we see here?
So as a software component, AI has the same common risks as typical traditional software component. So typically recently you use AI from OSS, or you may use SaaS service, or you can use third party. So so the common risks, I mean, when you use third party or OSS AI, then you need to copy it as sort of soup or unknown pedigree. So in this case, so you need to check, for example, copyright infringement, whether you can get sustainable support from the software provider or so on. And the next common risk is that open architecture poses risks. So suppose you use some company's SaaS service and use AI via its API. So openness-related risks in operation arise. So openness means you don't have full control of the AI as a software. So your service offerings consist of your part and SaaS part, and you need to identify what responsibilities you and SaaS provide should bear, and define you and SaaS provider should share responsibilities by the contract. So that's common risks. The same as the traditional way of the traditional software. And a unique aspect of the unique risk AI poses is that ethical or AI regulational risks. So AI ethical risk, AI can produce biased, unfair results or performance deterioration for some specific people. And so, for example, if the training data is biased, then the performance could differ depending on the personal attributes. And regulational risks as well. So because the technology is evolving very rapidly, the regulation is trying to catch up on the changing. So you have to be aware the regulation changes, ongoing regulation changes. You have to be aware.
So here, part of what your work there involves sitting on an ethics committee.
Yeah.
So what does that look like typically? So if what are the big concerns? What are the standard questions you guys ask? As much as you can share, obviously.
Yeah. So I serve as an AI ethics committee member of my company, Konica Minolta, and we have some businesses like surveillance cameras or inside nursery home, or also we have recently released generative AI SaaS service. So the typical question related to surveillance camera is how we can avoid ethical risks or privacy risks. So, and the new product or new services are take care enough, they can reduce the privacy risks. That's a very typical point.
Mhm.
And also we ship, so our company locates in Japan, and we ship the products to globally, Europe, America, and China. So we have to be aware that regulation changes in those areas.
Yes. So let's close by talking a little bit about generative AI. So,
Okay.
and the particular concerns you have with generative AI, you're beginning to use it. You have some tools that you're considering. So how is generative AI different in your sense, in terms of not different from an application perspective, but different from a software engineering perspective? What are the challenges that you're seeing in terms of developing, working with generative AI?
Yeah, so it's sort of the biggest concern, I think, is a sort of meta risk. I mean, the risk itself is not well understood. So hacking technique is being found very often. For example, I recently read a paper that you can ask ChatGPT the same question by multiple times, then you can get different answers, or you can crack the you can crack some safety wall. So there are multiple still unknown risks with generative AI, I think. So that's the biggest one. And so I can imagine multiple risks with generative AI. And so the major one is copyright risk. So we use, so for example, we use software generation tool like GitHub Copilot, but you know, GitHub and OpenAI is sued for license violation. So we have to be very careful to use those tools. We know a very powerful tool, but we have to be very careful to use if license violation is included in the generated code. That's one big thing, copyright risks. And also regulatory risks is a big thing, because the EU and the US, Japan, so many countries are updating regulatory risks. They are getting more aware of the potential danger of generative AI. So we have to closely monitor. The regulatory changes. So that's the next thing.
When it comes to safety, what are the safety concerns with generative AI? People are worried about it. You can hear it every day on the news. What do you feel the safety issues are here? Safety and maybe security as well.
Yeah. So I can give you two examples. So when we say generative AI, we can generate images or we can generate text. So in case of image generation, in some applications, they can apply generative AI to image enhancement or super resolution of those kind of things. It's traditional image processing, but also generative AI can also be used, but it can cause an artifact that does not exist in reality. So in medical image cases, if they use generative AI to, for example, a super resolution technique, then the generative AI can cause artifact or eliminate important features. That's one example. And other example for text generation is in medical software field is that you might create summarization of conversation between doctors and patients, and the generative AI can generate summarize sentences, can summarize, but the important critical information might be omitted or redundant, or additional false information might be added. So potentially, so those applications pose safety risks.
Okay. So thank you for taking time. I know it's late at night in Japan, so thank you for taking the time to join us.
Yeah. Yeah, thank you. Thank you very much.